All right. Hey, everyone. Our topic for today is going to be our graphing. We're still talking about graphing, but now we're talking about these things called roots. You maybe remember them from when we were doing our first day of graphing, and in Delta Math, it asks you to graph the roots. We're going to talk more about what that actually means to be the roots today. So the first thing is that we've got this quadratic roots. Let's define those. Quadratic roots are the points on the parabola. Remember, that's the shape of our quadratic equations. The points on the parabola that cross at the x-axis. So because these roots are such an important piece to our graphs, they actually go by a couple of different names. The first name is that they're just called the quadratic roots. The second name, though, is that they're called the zeros. They called the zeros because when we talk about our x-axis, that's where y equals 0. So when we think about our points that lie on the x-axis, they could be any number, but our y is always going to be 0. So our zeros are y equals 0. They also are called the solutions, because as we go on in this chapter, we're going to talk about how we solve these quadratics, and our roots, when we graph them, are the same thing as when we solve and get some solutions. The last one, when we graph these and they cross at the x-axis, is that they are called the X-Intercepts. So for our number of solutions, these could look a few different ways. We have either 2 solutions, 1 solution, or no solution. If we have 2 solutions, we have 2 roots. We have 2 places on our x-axis that our parabola will cross through. So it could look something like this. As long as there are 2 points on our graph, then we have those 2 solutions. Another option is to have just 1 solution. So we could have something where our vertex is actually the point on our graph like this that lies on the x-axis. So there will only be 1 point that is on the x-axis. The last option is if we have no solution, we could have some graph that's up off my x-axis and comes up this way. I could also have the same thing, but going down. So it never crosses the x-axis, so it has no solutions. Now, when we graph these, we're still going to graph these the same way. What we'll need to do, though, is we'll need to know the difference between graphing in standard form or vertex form. So when we graph in vertex form, the vertex form of an equation will have just one x. But if we have an equation in standard form, there will actually be 2 x's, an x squared and some x. There could be any numbers in front of that, but to know the true difference is a matter of having just one x or 2 x's in our equation. If we have 2 x's, we have a standard form equation. So for number 1 here, if I have y equals x squared plus 4x minus 5, this is in standard form. When we graph equations that are in standard form, we need to find our axis of symmetry. We can't just pull it out. So now I need to find a, b, and c from my equation. Well, a is whatever's in front of x squared, so that's 1. B is 4, whatever's in front of just x. And c is that negative 5, whatever was added on at the end. So we'll plug these into our axis of symmetry formula, negative b divided by 2 times a. And so b is 4, so that becomes negative 4, and 2 times a, 2 times 1. And if you plug that into your calculator, you would get that our axis of symmetry is at negative 2. So on our table, we'll go to the middle row. This time there's 7 rows, so I need to go down to the 4th row to get the middle, and we'll have negative 2 for x. Since negative 2 is my x, I'll plug in the values above and below to fill in the rest of my table. To find these other values, we're simply going to plug them into our calculator. I'm going to save you the hassle of doing that and do that for you here on this one. But it's good practice. So if you want to pause the video here, try plugging those values in. You certainly could. So you should have these values on your table to go with your graph. And so we'll graph those points real quick as well. So again, we're doing a lot of the same graphing and things that we've been talking about throughout the chapter, but we're now adding on just one more piece of information. Since we've got our graph created, we've got our values in our table, we now want to find the solutions to our quadratic equation. Well, we said there's two ways that we can see the solutions for our quadratic equations. If we're graphing them, they're the points where we cross over the x-axis. So I'll have one at 1, 0, and I'll have the other one at -5, 0. You can also see that on our table. When y is 0, x was 1, and -5. Now, because x is always going to be whatever number when y is 0, we don't actually care about writing the 0 part in our solutions. Our solution is going to be -5 and 1. To write that these are solutions, though, we're going to use curled brackets and say that these are answers. It's not a coordinate point. It's not my domain or range, so there's no brackets or anything. This is a solution. It's the answer to my equation. So I'll use curled brackets to show that that's an answer. Now, you could try one of these other graphing problems. I've got the example key posted in Schoology. So we've got 2, 3, 4, 5, and 6. So you'd be able to graph that and make sure that you're also able to graph these the same. I'm going to jump down next to the discriminant. So if you want to pause before moving on, you could certainly do that right now. Let's talk about the discriminant. So the discriminant, that's a new word for us as well. But the discriminant is a formula that's going to help us see how many solutions are in our quadratic equation. So in this space up here, we'll define that. The discriminant is the formula to show the number of, we'll just say zeros or solutions. I ran out of room, but you could say solutions there. And that formula goes here. We'll have D equals B squared minus 4 times A times C. So when we find the discriminant, we need our B, A, and C. Now C gets to be in our formula, whereas before we weren't able to put C in our axis of symmetry formula. This time it does. And when we do that, we'll get that D is some number. It could be positive, it could be negative, it could be 0. But depending on what it is, we'll determine how many solutions we have. So these over here are going to be our rules. So the first one here is if D becomes greater than 0, it's some positive number, we're going to have exactly 2 solutions. If D is equal to 0 on the dot, it is 0, there is exactly 1 solution. And if D is less than 0, it's some negative number, there are no solutions. So positive is 2, 0 is 1, and negative is 0. It's a little confusing, but make sure you have this little. So when we use the discriminant, we want to use these rules and making sure that we're using the number to determine which rule we're going to use. So positive 2, 0, 1, negative 0. Don't forget. So I'm going to try one of these. You can try it ahead of me, see if you can get the same solution numbers that I do. I'm going to do number 10. So if you want to pause here, get that discriminant, now would be a good time. So the first thing I'm going to do is I'm going to find A, B, and C so that I can plug those in. A, B, and C. So A is 2, B is negative 4, and C is negative 3. So in my discriminant, I'll have B squared. So don't forget your parentheses around negative 4 squared. Minus 4 times A times C. I always put parentheses when we're multiplying. And so when you type that into your calculator, we'll have our parentheses around each thing that I have parentheses, just like how we've typed it in. We just won't type the D equals part. And when we type in this problem here, we'll get that our discriminant should be 16 and I get 40 for my discriminant. And so if I have a positive number, that means that I have 2 solutions. And that's how we'll use our discriminant. Now there's a few problems in Delta Math for you to practice these skills on. So we'll do a little bit of graphing, we'll do a little bit of identifying, and we'll do a little bit of finding the discriminant value. So make sure that you're reading the directions carefully in Delta Math, but have a great rest of your day.